The piston is one of the most important components inside an internal combustion engine, yet it often goes unnoticed. Hidden deep within the engine block, it works tirelessly, moving up and down thousands of times per minute, converting energy into motion. But the story of the piston is much older than modern cars. The idea behind the piston dates back over 2,000 years. One of the earliest known concepts appeared in ancient Greece with a device called the force pump, invented by Ctesibius of Alexandria. This early mechanism used a piston-like motion to move water, laying the foundation for future engineering breakthroughs. Centuries later, during the Industrial Revolution, the piston became a key part of steam engines. Engineers like James Watt improved the design, making engines more efficient and powerful. These early pistons were large, heavy, and made of cast iron, but they demonstrated a crucial principle: controlled motion could generate useful work. The real transformation came with the invention of the internal combustion engine in the 19th century. Instead of using steam, these engines relied on fuel combustion inside a cylinder. This is where the modern piston truly came to life. When fuel ignites, it creates an explosion that pushes the piston downward. This movement is then transferred through the connecting rod to the crankshaft, ultimately turning the wheels of a vehicle. Over time, piston design evolved dramatically. Early pistons were simple and often inefficient, but modern pistons are highly engineered components. They are typically made from lightweight aluminum alloys designed to withstand extreme temperatures and pressures. Some high-performance engines even use forged pistons for greater strength and durability. Another important development was the introduction of piston rings. These small but critical components seal the gap between the piston and the cylinder wall. They prevent gas leakage, control oil consumption, and improve overall engine efficiency. Without piston rings, engines would lose power and quickly fail. Interestingly, the piston operates in one of the harshest environments imaginable. Inside the engine, temperatures can exceed hundreds of degrees Celsius, and pressures can be enormous. Despite this, the piston must move smoothly and precisely, often at speeds exceeding several thousand cycles per minute. Modern advancements have taken piston technology even further. Engineers now use computer simulations and advanced materials to optimize piston shape and performance. Coatings are applied to reduce friction, improve heat resistance, and extend lifespan. In some engines, pistons are even designed with special grooves and contours to improve fuel efficiency and reduce emissions. The piston may seem like a simple piece of metal, but it represents centuries of innovation and engineering progress. From ancient water pumps to high-performance sports cars, the piston has remained a central element in the evolution of machines. Today, as the world moves toward electric vehicles, the role of the piston is changing. Electric motors do not require pistons, which raises questions about the future of this once essential component. However, millions of internal combustion engines are still in use worldwide, ensuring that pistons will remain relevant for years to come. In many ways, the piston is a symbol of human ingenuity. It shows how a simple idea converting pressure into motion can evolve into a technology that powers entire industries and transforms the way we live. So, next time you hear the sound of an engine, remember that deep inside, pistons are working in perfect rhythm, driving the machine forward just as they have done for generations.